This slideshow will introduce you to C++ programming, and in particular, that programming for the Arduino Uno. Yeah. Silly bugger. The C++ programming language is called an object-oriented or OOP language. The reason is that there are objects already defined in the language that you can change, add, subtract, and change properties and also actions for them. Some of the objects that are in C++ are the function, which is a list of instructions, and a variable, which is really a container to hold some sort of value or data. Classes can be used to define a data type, and variables within a class are called attributes. All variables in C++ need a formal declaration before they are used in a function. So at the beginning of the program, global variables are defined. Functions need to be defined with any local variables, passing values to global variables, and also any values they are returning to the program. And we'll talk about that in a little bit. Normally C++ can have a number of functions, and the first one, or the controlling one, is called main. But in the use of Arduino, there are effectively two essential functions, and they are setup and loop. If you've done some work on the microbit, these are the same as the on, start, and forever loops that you see in that Arduino programming. Objects can be defined as functions, where they're a set of instructions that either calculate or manipulate the arguments, which are their variables, and they can return a value such as an integer or a string, or they might not return any value at all, and then the function is labeled void. In other words, nothing comes back from it. An example is void setup, which is the first procedure or function that you'll use with Arduino. And a comment by the double slash here is saying that it's going to be configuring pin 13 to be digital output. And then we set up a function that already exists, pin mode, and the LED pin, which will be number 13, and then whatever we want to send to it. If it's digital, it's going to be the high or low signal. And then we close that function with a curly bracket. We open it with the bracket, we close it. You'll also notice that functions have round brackets, open and closed after them, and that sets them up as a function. And then the curly brackets contain all the instructions that are in a function. This is the start function, and it's setting pin 13 on the Arduino board as the digital output. It's also sending an instruction and not returning a value. So that's why it's a void setup. Each instruction inside the function must have a semicolon behind it, but comments such as this don't require that semicolon. And functions, as I said, must be surrounded. The instructions or the code in the function need to be surrounded by their braces or curly brackets. Comments, as we said, start with a double slash. Variables are containers that might hold varying bits of data. That might be numbers, text, characters, Boolean operators, which are true and false, or arrays, which are lists of any of these variables. C++ expects a formal declaration of the data type. So if you use a variable without declaring it, it will give you an error. And it is not like Python, for instance, if anyone's programming in Python, you would know that the variable is defined by the value you give to it. You don't actually have to tell Python what sort of variable it is. However, C++ is, I guess, a little bit old-fashioned in the sense that it expects a formal declaration. Example of that is an integer variable could be age, all whole numbers, no numbers with decimal places. On the other hand, float for price, because price would have decimal places in dollars and cents or whatever currency you're using. Bool stands for Boolean, and completed task would either have true or false in it. And the string name, it's a string variable, and a name contains a number of alphanumeric characters, and that string then defines that it's able to hold that. By the way, string name, if it's got any numbers in it, it means that they're just numerals. They don't have any value. Same with character. It could be a letter, could be any alphanumeric character. There is no value of a number in character. It is just a character. Variable names always begin with a lowercase letter, and names of variables should be described and should describe the data contained. And some examples are name with the value of Harry, price with a value of $5.60, and letter with a value of uppercase B. Number variables have three main types. There's integer, which are whole numbers including 0. Floats, which are any number with decimal places. Just note that the E23 represents the number 6.023 by 10 to the 23. It might be familiar to some of you. Number variables have values, so they can be used in calculations. String variables contain one or more characters. And a string could be a name or an address. Again, 25 in the 25 High Street is just a numeral or a pair of numerals. It does not have any value. A character can contain one character, or char can contain one character. Response equals uppercase Y or 7. In this case, 7 would not have any value as a number. And you'll need to notice that all of the assigned data is surrounded by quotation marks, I beg your pardon, to demonstrate that either is a string or characters. Strings have no value, as we said. Bool contain true or false. These are used to hold the status of a condition or a flag. So you might have something that's on or off and you want to know what state it is in, then a Boolean variable can tell you that. The final variable is an array or list. This mirrors some of the properties of an array variable used in other programming languages. To set a list variable, you need to have the number of bits of data that you're going to be using and also what sort of data is going to be in there. The list of data needs to be encapsulated in square brackets. So for instance, string is the variable type, student list is the variable name for the list, and it's going to have 4 possibilities. So it could hold 4 student names, for instance. Integer is the type or the data type. Weekly sales is the name of the variable, and 6 is the number of integer variables that will be contained in the list weekly sales. Each element is indexed with a number and they start from 0. And global variables must be declared before the functions are defined. Global variables are active in any part of the program. Constants are used to define a specific value of a variable that will not change in the program. Example of constants are hash define LED pin 13. In other words, we're saying that if we use LED pin, it's going to be equal to number 13. Constant, integer, age. So in this case, it'll be a reference. So age will be 16 and it will be a reference to be used through the program. These lines of codes, LED pin to the value of 13, and the value of 16, as we said. In the case of the hash define keyword constant, the data type is defined by the value displayed. It doesn't need a formal declaration data type. And the value of setting a constant is that the variable is used a lot within the program. Its value can be changed by altering just this one line, the definition at the start of a program, and not every line in the program that uses this value. So for instance, if you're using a particular number that you want to use maybe a constant throughout the program, then put it into a constant value or constant variable rather, and this means that your constant will be able to use and it won't change through the program. If that constant changes, if you've just put it in as a number, you would have to go and change every single line that constant appears in. However, if you do it this way, you only have to change this once and the rest of the program will match your change. This one, oops, there we go, is that you use a 3-pin plug and it picks up the data pin, it picks up the positive voltage and the negative voltage, which is the ground. So there's your data, and these two are your power provided to a sensor or whatever other piece of hardware you can add onto it. Same with your analog, you've got the analog data pin here, then positive voltage, negative voltage. So that provides data and your power to your analog device that you're connecting. Just makes it a lot easier to connect. Flow control. There are several structures that you can use to change the way your program is running. Each block of code that you associate with any statement, as in a control structure, must be surrounded by braces. These include while and for loops and if and then and else decision-making structures. So let's have a look at if, then, else. These statements make a decision on the program depending on whether the condition, which is after if it is either true or false. So in this case, if we use both then and else, if a condition is true, then the instructions that come after then are executed. However, if this is false, then it ignores the instructions after n and carries out the instructions after the else statement. Once that's done, it continues on with the program. So let's have a look at an example. If the age is less than 18, do thing A, whatever that is. So do this set of instructions. Again, they're surrounded by curly brackets or braces. Else, if it's not less than 18, if it's 18 or greater, then do thing B. So that really is the control of that decision making there. Effectively, this is determining whether someone is less than 18 or not. Other things are loops. These repeat bits of code. A do while loop will continue to execute the code that is indented while the condition is true. It always runs the block of code at least once. So here we come along, do whatever the block of code is, and then check on the condition. If the gross salary is greater than 20,000, go back to the start, do it again. If it's true again, if it's still greater than 20,000, do it again. If the gross salary variable now has a value less than or $20,000 or less, it will stop the loop and go on with the next set of code. A for loop, rather, will repeat the indented code a finite number of times, and you can control how many times. The one below is repeating the code 10 times. So here we go here. For integer, 1 equals 0, there's your start. Up to the integer equaling, or rather being less than 10. Because it's an integer, then 9 would be the maximum. So 0, 1, 2, 3, 4, 5, up to 9 is actually 10 times round this code. And this one tells you to keep adding 1 each time it goes around the loop. So we execute our block of code the 10 times, and we close it again as we opened it with the curly brackets or braces. Okay, let's have a look at the Arduino program with some loops. Here we have the pseudocode. Now this, if you've done some programming before, you should be used to this. This is an English version of what's happening. So if the button on pin 10 is pushed, output a signal to 13, and if it's not, then output no signal to 13. How do we do that here? Here's our repeat forever. Then pin 12 button pressed, it's got to be either yes or no. If it is yes, then the output is high. In other words, a signal goes out to it. If there's no press of a button, the output is low. You can think of as high and low as on or off. The same with the touch sensor, which is on pin 11. If that happens, a signal is sent to pin 10. And if it's not, no signal is sent to pin 10. Now on pin 13, we might have an LED which would go on if the button is pressed, and we might have a buzzer here to detect touch. And when the touch sensor is touched, you would hear the buzzer buzz because the output is high. If it's not being touched, the output is low and the buzzer would not do anything. A library is a file of code that has been written specifically for some extra hardware. So each of the sensors that you are adding to your Arduino board will have a separate set of instructions written for them to be controlled by the Arduino using C++. Now, you need to get the appropriate library that will match your hardware, otherwise the hardware won't run. This library can be contained functions that allow you to use the added hardware, as we just said. The ones we're using are from a company called dfrobot. And the file for these functions is dfrobot_libraries.h. Any file that's being used in C++ programming with a .h on the end is a library of code. For example, we start off with our program, and here we go. We're including the dfrobot libraries.h. So all of the code relative to the stuff that dfrobot make is included in this library. Dynamic variables, if we're setting up a program. A volatile float means it's set up in Mine+, it's a number, and we're calling it temporary, temp. We can create an object from the library, from this library, for the LM35 temperature sensor, which is in your kit. So we've got our dfrobot_libraries.h already included, as we see here. We're now saying that dfrobot_LM35, which identifies our sensor, we're just going to call LM35 in the program. Saves us all this other stuff. Start the program, void setup, nothing to set up. Loop, mind n temp. Now temp is short for temperature. Mind plus variable has been set up a number, and then we go to the actual LM35 temperature sensor, and you'll notice there's a dot there. Why is there a dot? Because it says, okay, I'm in the library and I'm looking up the LM35 instructions, and one of those functions in there in the LM35 library is get temperature. So we want to get the temperature, and we also need to tell it what pin it's connected to. Well, it's connected to analog pin 0. Once we've done that, we can close that with a bracey or curly bracket. What happens then is the temperature, and it's in Celsius, or is then put into this as a number. And as we said, that's what the program is for. Functions, there are two basic functions that are essential for Arduino. They will be the void start. This is where you're setting up, initializing anything that has to be run once for the Arduino. Then you're putting in the loop, which is the one that is repeated constantly, and that will run whatever code is in here. The start function is executed when the Arduino starts up. It only runs once. The loop function, as we said, will continue. Examples of basic functions. Okay, let's have a look at one. Include dfrobot libraries.h. Volatile float mind mtemp. See, we've actually defined this variable in the start of the program. dfrobot underscore lm35 is the actual official name of that hardware library, but we're just calling it lm35. Void setup. There's nothing we need to do to set up this program. Void loop. And then this is what we do, is we say this variable gets a value of ln35 dot, in other words, the get temperature function that's in the lm35 library, and it's on analog pin 0. Close it, and as we said, it's coming from that library, and it's getting the temperature function from that library to then put the temperature into mind underscore n underscore temp. Do you have to have this with variables? No, you don't. But if you set your program up through Mind Plus, which we'll talk about later, this is how the variables are described. Basic commands. We really need to send information out to the sensors that we're connected to. One way of doing that is just to send a high or low as far as a analog, or 0 to 1023 if we're analog. The difference is that if we're reading digital pins on a pin number, and that's the number we have to indicate which number is this connected to, it's going to return either a high or low value, on or off. Analog pins, again, the pin number, and we're going to get a value somewhere between 0 and 1023. Same for writing. For digital pens, it's going to be a high or low, or basically on or off, and writing to an analog pin will send a value between 0 and 1023.